Good day and welcome to our third topic of the year, components of MV Switchgear. So Eben, you will give us more detail today about the components and how they are used in the different type of switchgears. So yeah, take us away.
Okay, so obviously we are now on the third topic on our calendar, and the whole year we are going to have some interesting topics. You can also browse the previous topics on our YouTube channel, which also covers quite a lot of interesting fields. So today we are going to speak about different kinds of components of MV Switchgear, and the first most noticeable one is circuit breakers. So a circuit breaker is very often mixed up with an isolator disconnector. People tend to think they are the same thing.
Yeah.
But the circuit breaker has got a very specific job, and that is to break a fault current. So it's not when there's a fault current and you just remove two contacts from each other, there's something which we call an arc, which is like a big flash, almost like lightning.
Yes.
Which we will cover extensively in one of the next topics. But for the sake of this, a circuit breaker is the only one that can actually open and manage that arc. Whereas the other ones, they can operate in nominal currents, but not in fault currents. So a circuit breaker, when you have a fault in your house, that's the thing in your DB that trips in your distribution board, that you have to go and switch on again. It can actually think for itself. It can analyze, is this situation proper according to its design, and then it will make a decision to trip or not to trip. Isolator, on the other hand, is more like a light switch. You can switch it on, you can switch it off, but it doesn't matter. Even if the house burned down, that switch cannot change direction. So it cannot open or close on its own. So that is an isolator or a disconnector. So both of them interrupt the flow of current, both of them isolate your voltage, but only one of them can actually break fault current, and that is your circuit breaker.
Okay. And then in what instance will you use a bus section?
So a bus section is a way to break up a board where you have more than one source, or where the fault current of the combined sources are too high. Then you would use a bus coupler to make sure that you cannot have a short circuit on both and feeding into the same fault level. That will then be much higher than what the switchgear can use. You can also use it in schemes where you have multiple sources, and you first want to sync your generators to each other, and then you want to close your bus, things like that. So it's an auxiliary kind of equipment that you can use in smarter design plans.
Yes.
It's not always necessary, but there is definitely cases for using that.
Yes, okay, cool. And then tell us more about the different types of cable compartments and the designs thereof.
Yeah, so cable compartments is quite interesting, is where your cable now comes in and connects onto your switchgear. There you have your bushings, which is the place where your cable come and connect. And then you have top entry and bottom entry is the two options of where the cable is coming in. Most of the time, 99% of the usage would be bottom cable entry. So the cable is coming from the bottom. There's the switchgear is either on a trench, or there's core drilling and the cable is coming through the slab or whatever it is the switchgear is on. And then it connects onto your bushing. So the bushing can be inner cone bushings such as Europe, and then also the outer cone type C bushings, which we normally use in South Africa and in most of the IEC markets. And your switchgear has got a plug that goes over that bushing. Your cables have got a plug that goes over that bushing where the cable is then fastened on.
Okay, great. And then the manometers, that's normally we use it in the gas insulated switchgears.
Yeah, that's correct. Yeah. So even in primary switchgear, you get circuit breakers, which is gas insulated circuit breakers. They also have a gauge, a manometer, something that shows you the pressure of the SF6 or the gas, that whatever gas is used inside of that switchgear. So in ring main units and secondary switchgear, you've got a manometer that will show you your SF6 pressure level, which should not drop below a certain level, and it should not be overcharged. So that is something that just shows you the level of the insulation.
What happens if you have too much insulation gas in your tank?
Yeah, so obviously every tank has got design limits, and the big problem is when you go up above sea level. So if you have quite a full tank and you go high above sea level, like to 2,000, 3,000 meters above sea level, the tank can actually pop. So your rupture plate will rupture, or the tank itself will get damaged.
Okay.
So it's not a good thing. A lot of people see a long green bar, a small red bar on the gauge, and they think that you should always be, you know, almost like a tank of petrol, but it's not like that. There's a design level. And then if temperature increase, it can go up a little bit. If height above sea level increase, it can go up a bit. But you don't want it to be at the higher end of the green.
Yes.
You just want it above the red. That's the safe levels.
Okay.
Yeah. So SF6 is very interesting. Even at low densities, it can still insulate quite a bit. But obviously with a little bit of pressure, you've got a higher density of SF6, or a higher level of insulation. Yeah.
Okay, then tell us more about the different type of relays that you can use.
Yeah, so relays is a very big field of its own. We've got a topic that covers quite a lot of relays on our YouTube channel that you can go and look at. But in terms of relays, you get basic overcurrent and earth fault relays, which can be self-powered or powered. So self-powered meaning the CTs generate the power that that relay needs. And the moment when current flows through that CT, then the relay is alive.
Okay.
Then other times it just waits, it's just dormant. And then you've got your powered relays, which needs an external source to power it. And that, you know, the smarter relays, which has got a bit of a computer on board, they will normally be powered relays. So everyone has got their field. Some relays are motor protection relays. Some relays have got sensitive earth fault for longer lines. So there's a lot of applications, and if the field of relays is quite interesting. And if someone needs more information, they can definitely contact us.
Yeah, most definitely. And then Eben, tell us more about the motorized and remote operation functions you get on MV Switchgear.
Yeah, so we see more and more people nowadays that want to build an automatic transfer switch, or they want remote switching capability. They don't always want to go to the sub to switch on and off in normal operation. Then they want to motorize the unit and give it remote opening and closing capability. So a trip and a closing coil that you can use to, say, from a SCADA system, you want to switch off a whole section of the plant for load shedding or for whatever. Then you can just send a signal and it opens and closes, and then the motor will charge the spring again. That is an add-on cost, but in a lot of cases, especially on automatic transfer switches, it is non-negotiable. You have to do it. So very, very interesting also how the market has evolved to become more of a motorized market nowadays. Previously it was very rare to get motorized, especially on ringmain units and secondary switchgear. Nowadays it becomes more and more popular, and we are selling hundreds of motorized units.
Yeah, no, definitely. Okay, great. So that is it for our episode of today. So stay tuned for our next episode, and then we'll see you again. Thank you.